Dan, nah, kalau wawancara kamu kan, Oh iya, nah ya ruangan ya.
Oh iya, iya. Cuman anu ya, care ya. Hah?
yang ada kacanya Di depan di belakang nih.
Di depan.
Ya. Kalau lagi Malaysia lagi.
Ini
Ada teman-teman. Ada nggak tuh?
Hah?
Plastik itu, ya. Dan plastik.
Plastik.
Ada risiko.
Ya. Ini jurusan itu baik. Ya,
Tidak, wah, hina dia. Oh, alam ini.
เริ่ม Hmm? Ya gile doang. Jam 10 toh. Waalaikumsalam warahmatullahi wabarakatuh. Jangan.
Cek sound. Halo, cek check in gitu. Ada suara.
Tarik nafas dan dikeluarkan, Bu Nur. Jangan sampai nggak dikeluarkan. Keluarkan dari mulut.
Biar nanti kalau close up, nanti kita bagi-bagi lah. Halo?
Loh, halo.
Oh, biar nanti nggak usah aja pakai apa namanya? Pakai headset karena itu sudah yang ngerekam. Jelas nggak, Pak?
Jelas. Oh, kalau bahasa belum, kita coba.
Pakai headset. Karena ini yang ini. Ya. Coba aja nih.
Apanya? Oh, bagus. Sangat bagus. Coba pakai headset. Oh.
Jadinya nanti Pak Ilham yang Pak.
Tuh, jelas suara sini. Makanya, iya. Baik, itu aja. Kalau mau di mode itu bisa. Gema deh. Ya wes, saya matikan. Ini aja nih kita mode. Tuh kan, nanti dia. Ya, biar nanti jam 8 sebagai ini setengah 9 kita puterin dia. Kurang tahu saya. Mau tidak pakai itu kedengeran kok jelas. Coba aja. Tanpa pakai headset. Picon kan ini voice. Yes. Saya sudah janji dia pakai lagi yang Telkomsel itu biar stabil. Bebas. Apa?
Oh yang
Speaker.
Saya matikan aja, pakai headset. Oh, makasih. Saya ganti kabelnya enggak bisa. Halo, cek. Coba benar. Halo. Halo. Gue sama. Yes. Yes. Oh, kamu ini. Wih, pengawas UP Jarin ini, saudara. Selamat datang Pak Kur. Iya kabar ya?
Coba aja connect.
Itu kan ikonnya.
roaming ini roaming. 201.
Apa ya? Ini aja nggak stabil asli, nggak stabil.
Enggak kita pakai internet sini, DPD.
Boleh, tidak pakai itu.
Maksudnya
Yang ini nggak berani saya pakai yang DPD.
Ini pakai apa?
DPD, makanya kayak gini ada.
lalu telang no.
Ada aku jangan libur gitu sebenarnya.
LMS gitu.
Assalamualaikum.
Kemarin harusnya apa Bu?
Jadi
Tas ya, tapi tadi tas saya properti nggak saya accepted. Tas ya. Nah, tapi di sistem sih, tampilan di jalan, maksudnya di sistem saya accepted. Kalau teknik juga cara
Waalaikumsalam. Tiang bawah nggak ada selokannya di sini.
Oh, iya nggak ada kerjaannya.
Iya, makanya itu astaga sudah semua. Oke, oke. Nah, kalau untuk apa namanya surround itu sekeliling itu gimana ya?
Ini kan udah saya setting kemarin ini. Nanti satunya itu ke seluruhan yang di depan. Satuannya itu ke tengah.
Oh, siap. Tiganya. Oke.
Nanti kalau balik tuh satu.
Oke.
Misalnya mau diputar, satunya aja.
Oke, siap.
Nanti kalau mau diatur, mau bayar lagi bawah satu aja.
Berarti sampai 4 ya?
Bisa ditambah.
Di sini aja lah cukup.
Jadi kalau mau diubah, misalnya nih saya kedua nih. Misalnya kurang zoom, tambah zoomnya, misalnya udah pas nih. Tinggal preset. Dua.
Berarti udah dikunci.
Ya harus preset dulu baru tekan warna yang dipakai.
Ya 2-3 hari lah.
Berarti kita nggak butuh jadinya ya apa namanya mikrofon karena itu sudah disantap semua.
Ya, cuman kalau mau jelas suaranya ini kan jauh deh nih.
Iya.
Jadi sebenarnya itu speaker sekaligus mikrofon.
Iya. Nah, gimana caranya supaya nggak scoring
ya? Enggak ada scoring. Meskipun pakai ini ke sini enggak ada scoring. Dicoba aja.
Wis Nur, Nur lagi live ini.
Saya awalnya kan
itu.
Halo, Assalamualaikum. Kabar Mas Bro?
Coba
Halo, Pak Wahyudi. Bos kita bagaimana kabar?
Oke, itu aja. Kirim.
Tes 1 2.
Assalamualaikum, Al-Mukarram.
Waalaikumsalam. Masya Allah. Bagaimana kabar Al-Haji?
Oleh Mas.
Di mana ini posisi?
Sedang menuju
bandara atau di hotel?
Sedang menuju.
Mau pulang nih.
Berangkat. Ya.
Suksesnya lancar acaranya.
Alhamdulillah. Rupanya kalau doanya Pak Yang berkah sampai sini.
Amin. Oleh-oleh katanya Pak Wahyudi ini.
Itu yang kita lupa kemarin. Nantilah insya Allah.
Enggak sih, just kidding aja.
Sedang briefing ya?
Ya, sedang briefing nih. Komandan kita Pak Wahyudi sementara.
Masya Allah. Mana Pak Irwan? Panitia? Terus pembicara?
Pembicara masih OTW katanya.
Sholat duha dulu katanya tadi kan?
Iya, sholat duha kayaknya atau sholat tahajud.
Masya Allah, sholat tahajud di siang bolong. Oke, dah lanjut dulu. Nanti saya.
Oke, silakan. Oke.
Dan.
Assalamualaikum.
Ya, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Ada suaranya?
Tapi agak delay gitu.
Jaringan
Makanya nanti
mungkin jaringan
ya saya pakai data. Mana? IndiHome itu. Biar khusus dan yang ini pakai IndiHome. Ini HP saya kayaknya.
ya.
Pakai XL. Itu yang
Oh,
bikin
yang
dia.
lain nggak ada yang masuk Zoom?
Sudah ada. Kedengeran suaranya? Ton. Kedengeran suaranya? Mana dia? Kalau laptop atau hah? Masuk. Mana dia?
Ya, pakai WST nomor 01.
Tuh, biar enggak
Internetnya pakai Winstar WS01.
Tes, tes. 1, 2, 3. Tetap ya. Ayo, Pak Ilham. Pak Ilham.
Tes 1 2 3. Iya. Halo, tes 1 2 3 dicoba.
Halo Pak Wahyudi. Masuk. Apa ini dimatikan? Apa ini dimatikan?
Atau punya aku tak matikan juga?
Matikan dulu.
Ini
Biar
sudah
situ fokus.
ini sudah mute aku.
Coba.
Pak Anu,
Sudah saya mau.
Kita kan naruhinnya Pak siapa namanya? Pak Dekan nanti.
Halo. Tapi enggak dia
enggak.
Halo. Halo. Oh, Yudi. Kenapa itu? Halo.
Kalau bisa volumenya sini.
Coba anu dulu. Bisa?
bisa coba lagi.
Enggak, masa kedengaran aja suara saya di sini.
Iya, tapi anu menggema.
Coba pakai
Coba
headset.
pakai headset.
Ya kayak pilot-pilot itu loh, Bro. Tangannya
Halo.
Penumpang, silakan.
Yes.
Tahu nyaman.
Halo. Halo. Lo. Halo. Ya headset saya mungkin ya. Saya enggak pakai itu juga. Tes 1 2 3. Kayaknya itu settingannya deh Pak Yudi. Coba ya. Halo Pak Wahyudi. Oke. Halo Pak Wahyudi. Mantap. Masya Allah. Melenggagah. Iya wah kena. Cocok.
Berarti enggak
Pak Ilham masuk.
pakai itu berarti.
Masya Allah. Yes.
Coba saya ya. Tes.
Nah masuk
Oh
masuknya.
ya.
Benar.
Tes 1 2 3 4 5 6 7 8. Ya Allah. Ini bukan speaker seharusnya. Dijual. Batiknya. Batiknya yang dijual.
Tinggal satu hostnya aja Twitter.
Apa?
Mau latihan dulu?
Ya.
Latihan dulu, pemantapan.
Bismillahirrahmanirrahim.
Jangan lupa tuh. Nah. Iya udah.
Ladies and gentlemen, may I have your attention? Salah intonasi. Hah? Boarding.
Boarding pass.
Ladies and gentlemen, may I have your attention, please? Our international webinar is about to begin. Thank you very much for preparing your... Sebentar ya. Balik.
Butuh minum?
Butuh minum saya.
Beneran?
Aida. Bismillahirrahmanirrahim.
Rukmi ini siapa Rukmi itu?
Hah?
Siapa yang jangan di-admit dulu? Jangan di-admit. Taruh di waiting room. Belum. Kita kan masih uji coba dulu.
Uji coba
Mohon
dulu.
maaf untuk moderator sama speaker, tugas Anda cuma menyampaikan, nanti untuk admit kami berdua. Jangan ikut-ikut ngadmit orang. Sudah, silakan.
Terima kasih.
Wali Kota. Saya. Bismillahirrahmanirrahim. Ladies and gentlemen, may I have your attention, please? Our international webinar is about to begin. Thank you very much for preparing yourself to join our international webinar. Tunggu sebentar ya.
Terus?
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. My name is Nur Hasana. I will be hosting you for today's webinar. And now, let me welcome our special guest for today. Welcome to the Honorable Mr. Dr. Jumarin as the Dean of Faculty of Education. The Honorable, the Head of Physics Education Department, Mr. Lalu Ahmad Didi Melyadi, MS. The Honorable, the first speakers today, Prof. Setsuya Nakada, and the second speaker, Mr. Irwan, PhD. The Honorable, all lecturers of the Physics Education Department, and the Honorable, all participants of this international webinar. Further, for the squares of this morning agenda, we will sing our national anthem. Ladies and gentlemen, please stand up. Berdiri.
Sebentar.
Belum.
Belum ya?
Memori.
Thank you very much. Please have a seat. Ladies and gentlemen, with honor, we would like to invite Mr. Dr. Jumarin as Ladies and gentlemen, with honor, we would like to invite Mr. Dr. Jumarin as the Dean of Faculty of Education to deliver a few sentences. To Mr. Dr. Jumarin, the time is yours. Pre-memory. Thank you very much, Mr. Dr. Jumarin, for the sentences. And now we are going to take a picture together. For all participants to please turn on the camera, and we are going to screen capture for the documentation. Ya, berdiri, kita foto berarti ya sama Pak Dekan.
Ya.
Berdiri apa duduk? Duduk ya? Oh iya dah. Duduk. Oke, we are done.
Not yet.
Tak hitung aja ya atau gimana? Gimana Pak Wahyudi?
Apanya?
Aku pas foto nanti tak hitung 1, 2, 3 or ya.
1, 2, 3 aja.
1, 2, 3 gitu aja ya.
Nah, yang ini kan pakai ini nanti.
Pakai itu. Oke, di capture ya. We are done. Thank you very much, ladies and gentlemen. Jangan ketawa.
Fokus saja ini.
Before the presentation begins, may I introduce our speakers today. There are two speakers today. The first speaker is Professor Setsuya Nakada, and the second speaker is Mr. Irwan, PhD. The first speaker today is Professor Setsuya Nakada. He is a professor of volcanology at Tokyo University.
Full screen.
He is Director General in Center for Integrated Volcano Research, National Research Institute for Earth Science and Disaster Resilience. His previous professional career are Research Associate in Faculty of Science, Kyushu University, Japan. Expert of Japan International Cooperation Agency at University of Mayor de San Andreas, La Paz, Bolivia. Visiting researchers at U.S. Geological Survey. Associate Professor at Earthquake Research Institute, the University of Tokyo. Professor at Earthquake Research Institute, the University of Tokyo. And now he is a Director General at Center for Integrated Volcano Research, Tokyo ya. Tokyo. Salah. Oh, San Andres ya, San Andres.
Butuh minum kayaknya Bu Bendahara. Iya, gimana? Saya juga butuh minum ini. Enggak ada apa.
Mana Isni.
Terusin aja.
Oh, lah, aset ya. So the curriculum vitae of Setsuya Nakada. Before we begin, let me briefly explain the rule of the first session. So we have a total 45 minutes for this first session. Because Prof. Setsuya Nakada has some business after lunch, so perhaps Professor Nakada will deliver talk on about 35 minutes for the talk, followed by approximately 10 minutes for question and answer session. All participants, you can ask questions by typing your question in chat box, or you can use raise hand feature in Zoom. And then unmute your microphone and camera. So that is the briefly rules. Ladies and gentlemen, now allow me to welcome the first speaker, Professor Setsuya Nakada, to deliver his presentation. Prof. Setsuya Nakada, the time is yours.
Fokus nggak bisa ya? Coba, nanti dicoba. Dicoba aja.
35 menit, totalnya 45 menit. Atau cukup? Atau 1 jam? Ini sih. Itu ya. 1 hour berarti.
Oh. Coba Pak Irwan, maybe you written now.
Kalau saya display yang saya gimana?
Langsung saja, bisa langsung.
Minum. Oh, di dalam. Terima kasih. Oh, aku unmute ya.
Siapa? Unmute, ya, oke.
Bisa?
Ya, bisa. Oke, cakep sekali. Slideshow. Ya Allah. Nah, nanti tugas kita, Pak Ilham, nanti pasti ada yang ganggu-ganggu itu.
Kenapa nggak dari awal di setting yang masuk-masuk angin?
Sudah. Mute, memang langsung mute ya kan? Yang
Udah kan udah.
Saya coba dulu bawa.
iya, speaker yang masuk sini. Speaker yang mana ya? Yang itu. Masuk. Kok bisa masuk? Hah? Kok bisa masuk? Ya masuk ya. Ya bisa sih masuk kan dia hostnya langsung dia on kan mikrofon.
Bisa dengar suara saya?
Bisa sekali.
For first time, I would like to say thanks to all of you for your time to join our international seminar. At this moment, I would like to start about volcanic eruption and geopark in Lombok, Indonesia.
Dengar nggak? Saya enggak.
Oh Yudi coba saya.
Admit.
Oh ini jelas nggak suara saya?
Kurang jelas toh?
Ambil teh.
Itu win start yang dipilih Bu5 bukan US.
Iya Pak, tapi enggak ada.
Usernya yang US.
Oh.
Tetap win start yang dan jam 9.30 masukkan semua.
Ini kan Bu siapa namanya? Bu Bendahara. Ribet.
Ayo coba Pak Waziri bisa nggak dengar suara saya?
Bisa kedengeran? Bisa Bang.
Coba ya, coba sekali lagi ya.
Pakai headset dulu.
Osman, please calm down, please. Okay. Yeah, so you can your voices make noise.
Tapi suaranya jauh. Suaranya jauh. Ini udah di
Kayaknya headset sih dia yang kurang kompeten itu.
Pak,
Tukeran.
ada Pak. Gak bisa.
Bisa dia, tapi terlalu jauh. Kalau saya deketin di sana story.
Makanya nggak usah dipakai itu kalau dari sana. Nggak usah pakai Ilham. Sorry Pak Ilham.
Bakal menoja gue ini kembali.
Suara dia balik. Oh, ini yang lebih bagus ini.
Ayo.
Gak apa-apa pakai ini aja.
Ayo.
Walaupun saya tapi bagus kualitasnya ini. Halo.
Sudah belum on kayaknya itu. No, langsung unmute bikin no. Oh. Ini baik muni.
Satu juga gitu.
Iya, tapi kan suaranya tadi itu terlalu kencang. Nah, coba Pak Yudi. Nah.
Sudah?
Iya. Halo, tes 1 2 3. Masuk. 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 Terima kasih Mbak Nevi.
Ya.
Coba ya. Tapi masa saya begini terus ya?
Ya dilepas saja.
Enggak apa-apa. Kedengeran?
Keras suara sudah.
Oke. Oke. Thank you so much. Bentar dulu ini. Thank you so much, Mrs. Nur Hasanah.
Ini kan yang ngedetek.
Kedengeran? Oke. Thank you so much, Mrs. Nur Hasanah. For first time, I would like to say thanks to all of you. Ini double malik ini.
Kalau tutup itu Pak ini kurir diisikan.
Apa?
Ayo, dicoba lagi.
Apa? Turin. Kurir. Mana? Nggak jelas kelihatan dari sini. Mana?
Ayo Ton, cek dulu lah.
Oke. Halo, Dede Wardina Usmano. Nih, kedengaran suara nih? Oh, ya.
Bang William.
Okay, thank you so much. Thank you so much, Mrs. Nur Hasana. Okay, for first time, I would like to say thanks to you for your time to attendance in the international seminar.
Karena saya cek aja. Ya. Udah.
Tapi nanti sistemnya gimana?
Ketika dia ngobrol,
Oke.
saya matikan.
Pas padekan
Padekan itu mikrofon yang itu saya hidupkan.
semuanya mati.
Ya, semuanya mati.
Coba tes kalau misalkan semuanya mati. Bisa nggak? Coba matikan dulu.
Mute.
Oke, tes. Bau? Bagusan ini ya. Nah, udah nih kalau headset ah menuju ya. Assalamualaikum warahmatullahi wabarakatuh. Paham? Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. Oke, pas ya, Nur? Oke, thank you so much, Mrs. Nur Hasana. Good morning everyone. First of all, I would like to say thanks to you for your time to attendance in international seminar. At this moment, I would like discuss with you about the volcanic eruption and geopark in Lombok, Indonesia. Jelas dia? Oh ini? Oh slow, lebih lambat. Oh Pak, terlalu cepat? Oke. Lana sedikit. Oke. Oke. Bisa dipakai. Oh ya, terima kasih. Anu dia. Coba sekali lagi Pak Yudi. Nah dia menggema dia. Siapa? Oh. Iya memang dari lahir sejak lahir.
Oh, kasihan.
Waalaikumsalam. Ini nggak ada jamak dibantu di sini. Nur, ini kamu. Apple. Black currant.
Ditata Pak yang bagus.
Oh iya betul.
Bu Rima. Ini
Sebentar, di narak kosong ya. Aduh. Kena kulit ini tuh. Aduh.
gimana ini?
2M. Dia ini di Pesemal berutang no. Dia mau tambah surga lawan. Bani. Pada kemati itu sebenarnya saya sahur utang.
Gimana jadinya pakai itu? Aku tetap pakai ini.
Enggak usah Nur. Jadi langsung pakai ini aja kayaknya ya. Jadi semua kita pakai ini.
Semuanya. Hah? Ya, udah. Coba ya.
Jika dibantu yang ngomong agak diketik. Saya nggak bisa ini. Stop share.
1, 2, 3.
Bisa?
Saya. Tes. Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum warahmatullahi wabarakatuh. Pak, kedengeran? Kedengeran?
Coba Bu Nur pakai yang mana sekarang? Yang itu. Oh, ini.
Ya nggak bisa.
Kok malah lebih jelas ya? Iya, pakai headset aja Bu. Pakai headset aja. Ibu nggak jelas suaranya tadi.
Oh.
Nah, baru ini jelas.
Assalamualaikum warahmatullahi wabarakatuh.
Jelas sekali.
Oke.
Coba sih deh.
Assalamualaikum warahmatullahi wabarakatuh.
Kurang jelas.
Coba.
Assalamualaikum warahmatullahi wabarakatuh.
Kurang. Yang tadi pas pakai headset Pak baru.
Nah, ya pakai headset tadi. Pak, ini kayaknya perlu dikasih di sini.
Oh ini komputer di sini.
Maksudnya ditaruh aja di sini gitu ya. Assalamualaikum warahmatullahi wabarakatuh.
Nggak ada suaranya.
Saya buka ini di sini speakernya.
Sida masih mute gitu, unmute.
Assalamualaikum warahmatullahi wabarakatuh.
Saya pakai mikrofon.
Itu matikan lalu matikan.
Assalamualaikum warahmatullahi wabarakatuh.
Nggak ada.
Ini dimatikan.
Tadi bagus tadi. Saya nggak ngapa-ngapain Bu Nesi, sungguh. Enggak. Pakai headset ya, bagus headset. Assalamualaikum warahmatullahi wabarakatuh. Kalau sudah settle, assalamualaikum warahmatullahi wabarakatuh. Kecil. Saya coba pakai headset ya.
Itu
Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Ya, oke.
Assalamualaikum warahmatullahi wabarakatuh.
Ibu Nur bisa dia masuk ke sini.
Tergantung amal ibadah.
Apaan? Nggak bisa.
Enggak, udah dua tadi kan? Benar mana belum ya?
Apa? Hah?
Jadi masalah nanti nggak bisa masuk. Berarti ini pas pandekan, berarti itunya dinyalakan.
Nyalakan.
Terus yang lainnya dimatikan. Terus pas selesai pandekan, itunya dimatikan.
Ya gitu aja dah.
Wah, tenang kok. Mudah-mudahan dikal lupa materi. Lelah. Speaker ini doang masuk stres itu. Dinara kayak aku angkat ke lupa.
Ada Kak.
Arang ke.
Itu di kelas kelasnya. Di dalam ada tapi kayaknya.
Iya nggak apa-apa. Ya betul Esti. Ya karena kita nanti ngomongnya lama. Ya minta tolong ya Dek.
Wah, coba cek dulu sebelum kita
Lihat. Assalamualaikum warahmatullahi wabarakatuh. Kedengeran, Mbak? Pakai headset. Kan jadi kadu headset dong Pak. No, mana ini? Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum warahmatullahi wabarakatuh.
bukan yang ini.
Oh iya. Assalamualaikum warahmatullahi wabarakatuh. Pas ya?
Jelas,
Enggak.
Ini udah dimatikan.
Kalau bisa lewat aja juga. Biasa masukin aja.
Soalnya kedengar suaranya orang-orang.
Assalamualaikum warahmatullahi wabarakatuh.
Udah ada ya. Pakai headset.
Thank you.
Jangan dilepas-lepas.
Ya, ya.
Assalamualaikum warahmatullahi wabarakatuh. Jelas? Oke.
Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh.
Oh, aneh. Saya coba atur dulu ya. Atau ini kita pakai headphone atau speakers kita pakai.
Kan ada on-off itu Pak. Ini kalau nggak bicara coba dimatikan dari itu.
Ini.
Nah,
Halo.
coba matikan.
Halo, tes 1 2 3 dicoba.
Matikan.
Udah ini.
Ada
Ini.
Bagus suaranya.
Coba. Bagus. Wih, dari tadi. Coba. Pas ya? Assalamualaikum warahmatullahi wabarakatuh. Innalhamdulillah.
Berarti nanti ini ya, kalau Pak Dekan
Bicara, kita kalikin sekali dah. Setelah kedua, oke dah.
Coba dulu sekarang matikan terus belajar. Itu
sudah mati saya. Saya sudah mati. Tes 1 2 3. Masuk.
Udah buka HP itu.
Enggak. Di HP. Enggak ada di HP. Loh kok?
Pak Irwan ini belum mati.
Kok saya connect?
Pak Irwan dimatikan.
Hah? Saya? Ya sudah, saya mute.
Saya keluar ini. Connecting Zoom. Ya. Udah. Ini barusan.
Your internet connection is unstable.
Coba Pak Irwan itu belum sudah
Unmute. Assalamualaikum warahmatullahi wabarakatuh. Oke, thank you so much.
Sudah ya?
Oke.
Ayo coba masuk ini. Yakin?
At first time.
Nah, kalau misalkan nanti supaya enggak kedengeran suara kita, nanti saya rubah di sini. Kedengeran nggak, Pak Ilham? Jelas?
Oh, ini dijelaskan.
Saya masalahnya enggak. Oke.
Ini gimana?
Jam 10 sudah kita mulai produksi. Jam 9.30 kita
Bisa nggak masuk? Masuk.
Ke dalam. Enggak, ke dalam. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. Oke.
Ini. Assalamualaikum warahmatullahi wabarakatuh. Jadi rubah-rubah. Ini rubah-rubah. Lelah keberangan.
Coba.
Pak Dekan.
Oke.
Ayo coba.
Pak Sari, Pak Widi ada ada dari UIN Riau, terus
Saya padekan di Riau.
Anda di sini cuma ada orang Riau sama PAI dia.
Terus
Tes, Assalamualaikum warahmatullahi wabarakatuh.
Sip.
Mana tandanya hidup dan tidak ini? Semua nyala nih walaupun ini.
iya itu.
Tes,
Masih?
dia ini nangkep
Nggak ada.
Dari situ aja, Pak.
Berarti dari sana. Apa ulang? Tes. Assalamualaikum warahmatullahi wabarakatuh. Bagus.
Iya, masuk.
Berarti dari Pak
Ini kalau full screen itu ada tombolnya. Kalau itu agak sekali. Sekarang mikrofonnya hidup ya.
Mana Pak?
Always.
Aduh, luar biasa.
pertanyaan dulu nyodok.
Iya.
Padahal kita sudah siapkan istri.
Oh gini.
Bawahnya lah.
Makanya saya nggak WA itu mungkin sedang repot. Dua tadi banyak yang lalu nama di daftar tunggu. Kilonya lumayan. Datang yang lu telat. Kamu bisa pakai headset nggak?
Ntar saya
Nggak, tetap aja kedengaran. Ini kan kamu pakai. Iya.
Apa caranya? Yang keliru, Pak. Jadi, pelajarannya kita masih tidak. Pak. Mau kita pakai bahasa Inggris mana tahu kan ya. Iya, jadi belum sih.
Denda aja.
Kita lihat fungsinya kayak ini
Wih, Pak Setsuya itu sudah on. Ustaz Ilham. Pak Irwan. Pak Irwan. Pak Irwan. Ya. Pak Ir. Pak Rob. Udah. Saya admit ya. Bisa Pak Dir. Dia aja. Selamat datang.
Jadi ini yang tema kita yang bikin sama itu sebetulnya di bawah ini. Yang nanti yang lupa ya. Gue ada folder, tema belum pakai folder. Asli ya, gue sama mungkin.
Sudah sampai, sudah saya jari kanan. Sudah unmute. Enggak, sudah saya matikan.
Hello. Hello. Good morning, Professor Session Nakada.
Hi, good morning. Can you hear
Hello.
me? Can you hear
Good
me?
morning, Sensei.
Okay. Good.
Yes, we all of us as fine. How about you, Sensei?
Yeah, good. But the Japan is very cold now.
Oh, really? This is
Yeah.
snow
This
right
morning, probably temperature is around 1 or 2, 3 or
now?
something.
Oh,
Yeah.
oh, so it's very cool.
Yeah, my car front. It's okay.
Yes.
Yeah.
Yes.
No problem.
No problems.
Yeah. May I check my presentation?
Yes, it's okay.
Yeah, I
if
want
you
to share my slide. It's okay.
Yes, it's okay. No
Yeah.
problems.
I try. Can you see my presentation?
Yes. We can see
Yeah.
clearly.
Yeah. I have some movie in my presentation. I want to check that.
Okay, please.
Moment. Yeah, moment. Here. Okay, this is a movie. So, can you see it?
Yes, it's worked.
Okay, good. Perfect. I don't know how to stop.
Just
Yeah,
pause.
okay.
Yeah.
Good.
Okay.
Probably everything is okay, I think. Okay.
Okay.
So this, yeah. So how many people join this seminar?
Yes, maybe probably 150 or
100.
200. Yes.
Wow.
Mostly students and lecturer.
Yeah. Okay.
Yes. Sensei, thank you very much for your time to attend us in our international seminar.
Okay.
Thank you very much.
Yeah. This is one activity of dissemination. Yeah. Very fine.
Yes.
Yeah. Okay, I will appear again 5 minutes before. So I close my
Yes.
video and the microphone.
Okay. Yes.
Terus itu pintar masak ya Mbak Wali?
enggak di gedung B dah ya. B ini enggak masih di gedung apa? Enggak. Yang selain gedung kita. Biar kita di gedung apa?
Irwan? Irwan? May I check again?
Oh yes.
Yeah, my talk is simultaneously translate to Indonesia, or you will some translation after my talk? I'm not sure. So
No.
no. So I can you hear me?
Yes. No.
Yeah.
I can hear you.
Yeah. So I will speak only in English.
Oh
Right?
yes.
Yeah. So
Yes, correct.
and not necessary to interrupt for translation.
No.
No. Okay. Yeah. Fine.
Sudah.
Bahasa Inggrisnya sudah siap.
Ladies and gentlemen, may I have your attention, please? Our international webinar is about to begin. Thank you very much for preparing yourself to join our international webinar.
Saya sering mengatakan museum itu apa?
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. My name is Nur Hasana. I will be hosting you for today's webinar. And now, let me welcome our special guest for today. Welcome to the Honorable Mr. Dr. Ahmad Azhari, to Vice Dean of Faculties of Education. The Honorable, the Head of Basic Education Department, Mr. Lalu Ahmad Didik Melyadi, MS. The Honorable, the first speakers today, Professor Setsuya Nakada, and the second speakers is Mr. Irwan, PhD. The Honorable, all lecturer of the Physics Education Department, and the Honorable, all participants of this international webinar. Further, for the squares of this morning agenda, we will sing our national anthem. Ladies and gentlemen, please stand up. Thank you very much. Please have a seat. Ladies and gentlemen, with honor, we would like to invite Mr. Dr. Ahmad Azhari as the Vice Dean of the Faculty of Education to deliver a few sentences. To Mr. Dr. Ahmad Azhari, the time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah wa syukrillah wa la hawla wa la quwata illa billah. Yang kami hormati dan kita sama-sama hormati our keynote speaker today, Mr. Professor Setsuya Yanakada, Tokyo University. Yang kami hormati keynote speaker yang kedua, Bapak Irwan PhD, Bapak Ibu Ketua dan Sekretaris Jurusan di Tadris Fisika, Bapak Ibu dosen, dan seluruh peserta yang hadir dalam kegiatan ini, baik dari PTKIN, PTU, maupun Bapak Ibu guru yang hadir secara virtual, dimanapun Bapak Ibu berada. Selamat bergabung di dalam International Seminar Volcanic Activity and Geoparks in Japan and Indonesia. Marilah kita sama-sama memanjatkan puja dan puji syukur kehadirat Allah Subhanahu wa taala. Alhamdulillah pada pagi menjelang siang ini kita bisa diberikan kesehatan, kesempatan untuk melaksanakan satu kegiatan akademik yang sangat luar biasa, di mana kita bisa bersilaturahmi dari ujung penjuru dunia, ya, dari luar maupun di dalam negeri bersama para pemikir-pemikir, ya, terutama yang berpikir tentang akademik yang terkini, ya, dalam Geoparks, ya, Volcanic activity. Geoparks ini jarang yang berpikir, tapi alhamdulillah kita bisa duduk bersama untuk mendengarkan pemaparan-pemaparan yang akan disampaikan oleh keynote speaker nanti, baik dari Prof. Setsu Yanakada maupun Bapak Irwan PhD. Salawat dan salam marilah kita curahkan kepada junjungan Nabi besar Muhammad SAW. Mudah-mudahan selalu menjadi inspirasi untuk kita dan mudah-mudahan kita mendapatkan syafaatnya. Yang kami hormati Bapak Prof. Setsu Yanakada dan Bapak Ibu peserta yang berbahagia dimanapun Bapak Ibu berada, yang ikut secara virtual pada kesempatan ini. Mudah-mudahan kita selalu diberikan kesehatan dan kesempatan dalam melakukan seluruh kegiatan akademik yang tentu memiliki hajat untuk kepentingan orang banyak. Di samping untuk meningkatkan mutu pendidikan, kemampuan kita sebagai tim di akademik, juga memiliki hajat untuk memberikan pemahaman kepada masyarakat tentang pentingnya materi vulkanik activity ini dan geopark yang ada di Indonesia maupun yang ada di Jepang. Kami dari pimpinan Fakultas Tarbiyah dan Keguruan UIN Mataram merasa bersyukur dan sangat berterima kasih kepada seluruh komponen, terutama dari pihak Prodi yang sudah menginisiasi kegiatan ini, terutama sekali kemudian dari keynote speaker kita dari Tokyo University yang bersedia untuk membagi ilmunya untuk kita semua, sehingga apapun yang nanti disampaikan, mudah-mudahan itu berkah untuk bagaimana pengembangan lembaga, satu, yang kedua untuk pengembangan ya kemampuan akademik Bapak Ibu dosen kami yang ada di Tarbiyah khususnya, dan Bapak Ibu yang menjadi peserta dimanapun berada. Kemudian harapan kita bahwa kegiatan seminar yang diadakan seperti ini adalah kegiatan yang terus berlanjut, sehingga terjadi sebuah konsep akademik yang penting, ya, yang bisa menciptakan bukan hanya silaturahmi akademik, tetapi bisa kemudian menggandengkan antara satu pemahaman konsep-konsep keilmuan yang ada di berbagai penjuru, di tingkat PTKI, PTU, maupun yang ada di luar. Sehingga kita kaya dengan khazanah keilmuan yang bisa membangun dan bisa menciptakan sebuah situasi akademik yang kalau dalam istilah Plato adalah bagaimana kita membangun, membumikan akademik ini sebagai sebuah sistem yang dia berjalan ya dalam sebuah konteks yang lebih ini terus melakukan inovasi dan perbaikan serta lakukan yang disebut dengan peningkatan. Yang terakhir kami sampaikan salam Dekan Fakultas Tarbiyah dan Keguruan FTK UIN Mataram Dr. Jumarin. Kebetulan pada jam yang sama kami ada kegiatan yang sama sehingga diwakilkan ke saya sebagai Wakil Dekan 3 untuk memberikan sambutan dalam kegiatan ini, sekaligus mungkin membuka acara kegiatan ini. Ya mudah-mudahan kegiatan ini bisa berjalan dengan berkah. Terakhir sekali saya sampaikan terima kasih kepada Prodi dan semua Bapak Ibu dosen yang ada di Tadris Fisika dan beberapa dosen yang ada di FTK ini ya. Alhamdulillah ya dengan kerja keras dan dedikasi yang tinggi, alhamdulillah kegiatan ini bisa dilaksanakan dengan baik dan bisa menyambungkan ya bagaimana kegiatan akademik yang ada di UIN Mataram dan yang ada di Tokyo dan di beberapa PTU dan PTK. Demikian yang bisa kami sampaikan. Dengan mengharap ridha Allah Subhanahu wa taala, marilah kita buka acara International Seminar Volcanic Activity and Geoparks Japan dan Indonesia dengan sama-sama melapaskan basmalah. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Mr. Dr. Ahmad Azhari, for your synthesis. And now we are going to take a picture together. For all participants, please turn on the camera and we are going to screen capture for the documentation. Please turn on the camera. Okay. 1, 2, 3. One more. 1, 2, 3. Okay, we are done. Thank you very much.
Tugasnya Pak Irwan menjelaskan apa yang saya sampaikan dengan lebih bagus dan dihaluskan.
Okay, before the presentation begin, may I introduce our speakers. There are two speakers here. The first speaker is Professor Setsuya Nakada, and the second speaker is Mr. Irwan, PhD. Okay, the first speaker today is Professor Setsuya Nakada. He is a professor of volcanology at Tokyo University. He is a Director General in Center for Integrated Volcano Research, National Research Institute for Earth Science and Disaster Resilience. His previous professional career are Research Associate at Faculty of Science in Kyushu University, Japan. Expert of Japan International Cooperation Agency at University of Mayor de San Andres, La Paz, Bolivia. Visiting researchers at U.S. Geological Survey. Associate Professor in Earthquake Research Institute at University of Tokyo. Professor in Earthquake Research Institute, the University of Tokyo. And now he is a Director General in Center of Integrated Volcano Research, Tokyo. So that's the curriculum vitae of Professor Setsuya Nakada. Before we begin, let me briefly explain the rule of this first session. So we have a total 1 hour for first session. Because Professor Setsuya Nakada has some business after lunch, so perhaps Professor Nakada will deliver talk on about 45 minutes for the talk, followed by approximately 15 minutes for question and answer session. All participants, you can ask question by typing your question in chat box, or you can use raise hand feature in Zoom and then unmute your microphone and camera. So that is the briefly rule. Okay, I think that's enough. Ladies and gentlemen, now allow me to welcome the first speakers today, Professor Setsuya Nakada, to deliver his presentation. Prof. Setsuya Nakada, The time is yours.
Thank you very much. So first, I would like to share my presentation. It's okay?
Okay.
Yep. Okay, thank you for my introduction. And yeah, at first, selamat pagi. So as
Selamat pagi.
as introduced, I am a volcanologist and now working center of research in the National Research Institute. So about 3 years ago, I retired from the University of Tokyo and I moved to Tsukuba now. And I'm very happy to give a talk about this title in the international seminar on the earth sciences by the one of the youngest university in Indonesia. So I also study some volcanoes in Indonesia, for example, Sinabung and Kelut and other volcanoes. So, but unfortunately, I can't speak in Indonesia. Very sorry. Okay. So the next, how to move. Okay. Yeah, purpose of my presentation here is to increase your awareness, knowledge about volcanic activity in Japan, which is will be compared with Indonesian volcanic activity. So the second purpose is introducing geoparks in Japan. So the geoparks is utilizing the volcanic heritage, and they try to reduce volcanic disaster risks. So geoparks is very effective tool to for disaster risk reduction education. So in Japan, now we have 111 active volcanoes. So here active volcano is the same as in Indonesia. The volcano has records of eruption within these 10,000 years, or a volcano presently showing some manifestation of humoroids. So probably you know one of the most active volcano in Japan is Sakurajima. However, throughout Japan, the recent activity is very low. So compared with Indonesia, I show you next slide. So right on the side is my favorite volcano taken by myself. This is Nishinoshima. So today I focused on the two topics of the island eruption or submarine eruption recently occurred in Japan. So this shows the temporal change of volcanic activity among Japan, Indonesia, and Chile. Chile is just example. So the vertical axis is volcanic explosivity index. This is a sort of magnitude of earthquake. For example, magnitude 3 is moderate eruption, 4 is large eruption, 5 is huge eruption, 6 and 7 magnitude of a super eruption. For example, this is Krakatoa, this is, I don't know, Tambora, and this is Krakatoa. So when we look at this figure, so very strange thing. So Japan has no big eruption of VI5 since 300 years ago. And the huge, large eruption, VI4, we have no eruption these 100 years. So very strange thing. But I don't know why this strange thing occur in Japan. So the other word, the Indonesia is more active than Japan in volcanic activity. So recent submarine eruption I introduced later, maybe VI4, the large eruption, but the scale is not very is difficult to determine. I show you later. So this is a map showing the distribution of volcanoes in Japan in Izu Ogasawara arc. So upper left is Tokyo and Mount Fuji is here. Izu Oshima, Miyakejima, Sachijojima, and 1,000 kilometers south of Tokyo, we have here the Nishinoshima, and here Fukutoku Okanoba. Two volcanoes introduced today. And other examples, Ioto. Ioto is the place of battle in World War II. In the very severe fight occurred between Japan and the United States. So this island, Ioto, is an example that is one of the most actively uplifting volcano in the world. So rate of uplifting is 1 meter per year. So after the World War II, U.S. Army sank many ships in the shore to make a harbor. But now those sunk ships appeared on land due to the strong uplift. So those areas is very active in Japan now. So Nishinoshima is located here. Started eruption 2013 and continued now, but almost stopped last year. And as an example, Fukutoku Okanoba. Fukutoku Okanoba is named after the name of ship Fukutoku, and the Okanoba means the shallow water. So this means the shallow, very shallow, some sort of knoll. Nishinoshima means the island, western island. This is located the Chichijima. This is island people are living now in the west of Chichijima, so that name Nishinoshima. Okay, this is the eruption which occurred 13 August this year, Fukutoku Okanoba. So height of the plume, ash plume, reached 16 kilometers above the sea level. This is very big. So only depending on the height of the plume, probably this is VI4. But as I show later, probably the magnitude is as large as VI3, I think. The image of the topography around the Fukutoku Okanoba, this is Fukutoku Okanoba. And the eruption started here. This is another the ancient volcano. So after the eruption, 2 weeks after the eruption, we can recognize such kind of islands, small island. This island is made of pumice, many pumice and pumice blocks create this kind of islands. The volcanologically, we call this pumice cone. This pumice cone appeared eruption soon after the eruption, but the erosion eroded most of those islands. Presently, we can witness only a small part. A serious issue of this eruption is a huge amount of pumice drifting from this volcano. This is 3 days after the eruption, and this is pumice raft is drifting. away from the island. This is Fukutoku Okanova eruption occurred here. So this is a picture taken from satellite. The satellite name is Landsat 8. So 2 days after eruption, pumice cone is shown here, and a large amount of pumice is drifting due to the sea wave, and this is pumice raft. And 4 days after the eruption, just image shown in last slide. And September, 1 month after, 2 weeks after, this shape is like this. And November, middle November, size of like this. So when I visited there using the jet plane of mass media, so hiring a jet plane is very expensive, and the normal helicopter or the propeller airplane is difficult to reach here. This is so far from the Tokyo, so 1,300 kilometers. So that we asked mass media. So this island is very very high in news value. So please pick up me to there. So several times I used the mass media plane to observe those islands during the eruption. So this is a close-up view of scoria cone. Here is the pyroclastic flow, and here is the pumice flow and the pyroclastic surge and pyroclastic flow and pumice flow. This is based on the photograph. So yeah, detail may be wrong, but we can understand there are 2 episodes of eruption. So one episode started the pyroclastic flow, and which was continued by the pumice falling of pumice and small surge. So we try to estimate the eruption scale. So only based on the plume height, the volume is estimated VI4. But here is sea area. Sea area is very difficult. So seawater create steam. Steam generate the increase height of the plume, so that we estimate another way. So we estimated the use the diameter of the crater. So this showed the relationship of diameter and eruption volume of the documented eruptions. So here is the line of phreatic eruption, phreatomagmatic eruption. So this is the case. The case of Fukutoku Okanova is a phreatic eruption. So that we used this relationship, and we got the volume of 0.07 cubic kilometer. So this is magmatic eruption. The case of magmatic eruption, energy is smaller than magmatic, the phreatomagmatic eruption. Even the magma volume is the same. So that our conclusion is probably this eruption scale is VI3 plus, yeah, almost 3. So the big concern is the pumice raft drifting. This causes a serious problem in Japan. So this pumice raft reach to southern coast of Japan, that makes a serious problem. So this is 4 days after the eruption. This is pumice craft is moving westward, and yeah, okay. So here is Okinawa. Okinawa is the southwestern part of Japan. So this white color is the pumice, pumice is accumulated inside the port. So this is a close-up view of the beach. So 2 months after the eruption, those pumice raft reached those area. So this is called a serious issue. So for example, fishery is impossible. So we can't use a boat, fishing boat. And the sea surface transportation is cause a serious issue. And resultantly, tourism become very difficult. Fishery, tourism, and others cause serious issue in Okinawa. Now in the southern part of Tokyo also met a serious issue. And this floating material finally give influence effect on the ecological system, especially coral reef. So the drifting of pumice raft is simulated by the scientists. JAMSTEC is Japan Agency Marine Science and Technology, simulated the detail, and they announced the forecast the reaching the pumice raft. So pumice raft is very similar to microplastic. Microplastic is a very serious problem of the environment of this ocean, and also they create some climate change, the reason of climate change. But pumice is made of glass and crystal and pore. The glass crystal and the pore making a pumice. So the glass gravity is very high, more than 2, the specific gravity, so that they finally sink and deposited on the sea floor. And part of the raft is able to be removed by people. On the other hand, the specific gravity of plastics ranges from 0.9 to 1.4. The majority of microplastic or microfiber is floating within the seawater. So they tend to be drifting within the sea for a long time. So in some sense, drifting pumice and microplastic are similar, but the final effect is completely different. So this is next volcano. My favorite volcano is Nishinoshima. Again, this was taken by airplane jet of mass media. So I show you a movie. Oh, moment. Oh, doesn't move. Okay. Okay. Oh, sorry. Okay, Nishinoshima is again the submarine started with submarine eruption. So this is November 2013, and this island became larger with time, and combined with Old Island formed 1977, and repeating eruption, this island became larger and large. So this volcano itself, this island itself is a huge volcano standing from the minus 3,000 meter. So very huge volcano. Just the top of the volcano we can see on the surface. And 2017 April, and this volcano continued the eruption by the emitting lava flow. This style of eruption is completely different from Fukutoku Okanova. Fukutoku Okanova eruption was only one day, and a huge amount of pumice deposited on the sea surface, and easily eroded by seawater. But here, this volcano grown by the accumulation of lava flow. So there is no way to remove it by seawater. But when the crater was deepened and the magma contacted with seawater, and flared magmatic eruption started. And after that, the whole surface of lava flow was completely covered by volcanic ash due to the very strong fragmentation magma by interaction of water. So this is the latest feature of this volcano. And this is the map showing growing pattern of this Nishinoshima. This is old island, and the new eruption started in the sea nearby, and the grew like this. So this is our the observation, the size of volcano, the height of volcano, and volume of island. This was based on the picture or some satellite image. And also we collected a sample by drone or the 2 times of landing. And this is SiO2 content of lava. So this started 60 is underside, and chemistry didn't change for a long time. And finally, magma changed SiO2 poor. So this is a basaltic andesite. So magma discharge rate, eruption rate was also estimated based on our estimation using photograph. And this is time of the eruption. This is break, eruption, break, eruption, break, and eruption. So final stage, we call this episode 4, was strongest among the recent eruption at Nishinoshima. So next talk is Geopark. Probably you knew already about the Geopark. Geopark is not only the geological park. This is a sort of system to protect nature heritage. So this is one of UNESCO nature protection program, World Heritage, Biosphere Reserve, and IGGP. IGGP is International Geoscience Geoparks Program. So the Geopark program is one of IGGP program. So what is Geopark? So in the statute of this program, clearly written that UNESCO Global Geoparks, the mechanism of international cooperation by which area of geological heritage of international value. So international value heritage, geological heritage is a key of geopark. And the method is a bottom-up approach to conserve the heritage and support the other heritage, for example, culture of nature. And the purpose is development of local community. And this is a very unique program of UNESCO Global Geoparks. So, in the guideline of UNESCO Global Geoparks, there are 8 criteria. So one is first is single unified area, including geological significance sites, and the second is connection with natural cultural heritage is very important. So this connection should be used to access key problem of our planet Earth. For example, geohazards, climate change, and natural resources are very the important issue of future planet of Earth. And third is managed body is legal, should be a legal existence. And the fourth is if it overlapped with another UNESCO program, you have to justify the value of Geopark and should show the synergy of the overlapping of UNESCO program in this site, in this area. So 5 is the involvement of local community, and especially if indigenous people existing there, you have to keep the good connection to protect, to proceed Geopark program. And the management body must participate directly in the scale of what you mean? Yeah, so all community or stakeholders should be involved in this program. And sorry. So the network is a very unique system. And in the site, you can sell any geological products or souvenir. So like this, the keeping criteria is important in Geopark to keep the quality of the Geoparks, so that we have some checking system many times. So this is a distribution of Geoparks in Japan. So this shows the number of Geoparks in individual countries. And China is totally 169 UNESCO Global Geoparks in the world from 44 countries. And China is the most biggest number of geoparks. And the second is Spain, third is Italy, and the fourth is Japan, and the fifth is Germany and France. Sorry, this is United Kingdom, sorry. This is Germany and Greece, and here is Indonesia. So Indonesia has 6 UNESCO Global Geoparks and third biggest number in the Asian country, China, Japan, Indonesia. So this shows a change of number in geoparks in Japan. So UNESCO Global Geoparks, we increase the number spending 10 years. So using 10 years, the number reached 9. But in your case, the only 5 years activity, you can get 6 UNESCO Global Geoparks in Indonesia. This is a very good success. So this shows the national geoparks. National geoparks will be the candidate of future UNESCO Global Geoparks in Japan. So we recommend making national geoparks before UNESCO Global Geoparks. But the number, almost stopped around here. So this is a reason. So after the UNESCO program programming 2015, the geoparks are the standard become the harder, and the local community started watching the benefit of geopark, so that they started hesitation to submit the geoparks in Japan. But we promote the increase the number of UNESCO Global Geoparks in Japan. So the characteristic of Japanese geoparks is first a strong national geoparks network, and we insist the storytelling. It's very important to understand the connection with geological heritage with other the heritage, and the most people are focusing geology on the regionalism rather than the tourism. This is very typical characteristic in Japan, and they weighted and education, especially related to disaster reduction, and as well in Indonesia. So the Japanese geopark managed by municipalities. This is not a real bottom up. This is just a middle up or middle down. So the merit is easy communication. The making curriculum of education is very easy because due to the strong involvement of municipalities. But the demerit is sustainability. If the leader doesn't want to continue geopark, suddenly this geopark may stop. This is very the strong demerit of this system. So this is ankit of geopark community. So majority want the community improvement using the geopark, and tourism is here. So tourism is not the most interesting thing for them. People among people promoting geopark in Japan. So here is distribution of geopark in Japan: 9 UNESCO global geopark here, and 35 national geoparks. They are making a national geoparks network. So this network is very important to keep the quality of geopark, and the making the Japanese characteristics comparable to the other countries. So this is a framework of plate tectonics in Japan. Here is Japan Island, and here there are 4 tectonic plates merging. So this is continental, 2 continental plate is the converging here. So 2 oceanic plate is subducting under the Japan Islands, and the Pacific plate is subducted the further the Philippine Sea plate. So the subduction of oceanic plates generate a frequent earthquake, volcanic eruption, like Indonesia. So this is very strong characteristics of Japan. So geoparks distributed here, the only UNESCO global geoparks are shown here: 1, 2, 3, 4, 5, 6, 9, and characterized for example, 1, 2, and 3 volcanic geopark, and 4 and 5 is a plate boundary, 4 and 5, and also accretional complex prism in the Muroto is here. Accretional prism in the here. This is subducting plate. Sediment on the ocean floor is accumulated, pushed to Japan Island, and here accretional prism complex is produced. This is a good example of showing the earthquake generation, and 7 is the collision of plate, and the Philippine plate is collided against the Japan Island, and the formation marginal basin. So Japan originally contacted to the continent, but separated Miocene time is around 15 million years ago. Japan Island started separation from this China continent, so that the Japan Sea was created as a marginal basin. So this is a summary of characteristic of Japan geopark. So I show you briefly the the 9 geopark. This is Itoigawa geopark located here. This is the boundary between two continental plate, North American plate and Eurasian plate. So visitor can touch both of continental plate at here. So here is Itoigawa. This is a map showing from the north on the globe, a map of globe. The Katra has the same boundary with Itoigawa geopark. So this is a map showing the earthquake. So in the site you can see the QR code. By QR code you can see the present activity of the earthquake. Here is Itoigawa geopark. The site is here. You can look the distribution of faults and distribution of recent earthquake. You can change the duration of a period of the earthquake. And Apoi is here. This is Hokkaido, south of Hokkaido. So this is very unique geopark. You can see this is peridotite. Peridotite is a material of upper mantle. This shows the youngest exposure of fresh peridotite in the world. So the child is polishing a peridotite for her pendant, and this site is very unique, so that many scientists visit to run the peridotite. And I know this is one of the famous indigenous people in Japan is involved in this geopark organization. And acquisition of prism is Muroto. So this is a sketch of acquisition of prism. So repeating acquisition, the earthquake occurred and big thrust is formed like this. This is a deposit of the acquisition of prism. This is made of turbidites, and many uplift marine terrace was formed by the creating uplift. So this is a local products of charcoal and the sea gourmet, and also they show the uplift dance during the evaluation of geopark. So opening Japan Sea is shown in the Sain Kaigan geopark. So here very beautiful volcanic column, columnar joint, and this is scenic the cliff along the shore. And this is very interesting thing is the geomagnetic reversal was found in this outcrop. So this the hot spring resort along the active fault. So this is as the seashell, the habanero, or the crab. It's another geopark in the Japan Sea, the Aoki Island. Very beautiful green cliff developed along the island. So due to the isolation of this island, this was used for the exile place. Two emperors were banished during 13th, 14th century. So this is very good linkage to cultural uniqueness, and ecologically also showing the uniqueness. And two emperors here, and a shrine was formed inside the volcanic rock. So due to the exile of two emperors, there are many temples in this island. So collision of plate is a peninsula here, located here, very beautiful submarine volcanic products. And the beautiful scoria, 5,000 years ago, latest eruption of this island, this geopark. So the Philippine Sea plate migrated toward this island, and here is a location of collision. So you can enjoy the geoproducts. Geoproducts produced by her. For example, this is a cookie of columnar joint biscuit and cross-laminar biscuit. Also, this is obsidian candy, and this is a scoria cookie. So risks from natural hazard is a very important issue. So this is a volcanic belt, and another volcanic belt running from Hokkaido to the Nishinoshima and the Fukutokuoka. So this is the hazard map showing the probability of a quake and of earthquake. So, for example, Muroto and Izuoshima are facing within the dangerous place of risks of from the earthquake. So this is a record of the natural hazard, Unzen eruption. 30 years ago, 44 fatalities, very small. Compared to this Kobe earthquake and Tohoku earthquake tsunami, the huge number of these, the casualties. And Ontake eruption is the largest after for these 100 years. And the Kumamoto earthquake is another issue I show you later. So this example of 30 years ago pyroclastic flow occurred in Unzen, UNESCO Global Geoparks. This is the pyroclastic flow approaching to the fire car and the fireman. And 2014, suddenly eruption occurred in the Ontake volcano without any clear precursory phenomena. So at here, around 200 or 300 people are resting on the top of the volcano. This is a very beautiful hot day, and autumn, the very beautiful day, beautiful season. But this was unlucky because time is noon time, so many people eating around here. Sorry. So this is one of the example of disaster. Mount Aso is another volcano, UNESCO Global Geopark. This is a caldera, the 20 kilometers across, and within the caldera, 50,000 people are living. So the eruption which produced this caldera was VA7, like Rinjani or Tambora. So this occurred 90,000 years ago. So very beautiful scenery of caldera. And yeah, Aso is here. And the 5 years ago, earthquake attacked this geopark. So the repeating strong earthquake occurred along the active fault zone, and the shrine collapsed like this, and many landslides occurred, and the many people died, including a student. The number of deaths is direct to death is 50, but related deaths reached around 300. So within the geopark, very beautiful active fault appeared like this. And the 6 months after the earthquake, eruption occurred like this. So that Mount Aso, the dangerous place, repeating the earthquake and volcanic eruption. Lesson from natural disaster. So the geopark is very excellent outdoor class to learn natural hazard. And also the community, they helping each other. They are removing the volcanic ash deposited on the roof. And the eruption, the experience was shared in the children's schools. And another example is the Us volcano. Us Toya caldera is here. Us volcano is here, and it's located in Hokkaido. So at here, they are creating the growing Volcanomeister. Volcanomeister is very interesting. This is a sort of guides, the introducing volcanic activity, and their aim is to transfer the experience of eruption. Oh, what did this? Okay. So the this is the 1977 eruption. This is Biraj, and 2000 the another latest eruption occurred here. So the local community, they may create a certification system of this Volcanomeister. So this is supported by local government and volcano researchers. And now the over 50 Volcanomeister have grown up. So for example, he is a Volcanomeister, one of Volcanomeister, she is also Volcanomeister. She is introducing this scenery as a geopark and also telling the story of how to prepare the future eruption. The another example is Unzen volcano. Unzen volcano, 30 years ago, the ruin of the vehicle burned by pyroclastic flow is shown here. This is guided by tour guides, and elementary school attacked by the pyroclastic flow 30 years ago. It remained ruin, telling the story of the eruption, and how this is buried by lahar, also shown, and big tent. So they are holding many workshops. So they are creating the geo guides who are expecting to act as community leaders for minimizing risk when next disaster happens. So one of the lecture is a driver of this fire car. 30 years ago, he was a driver of this fire car. And he's telling on his experience for local children, to the local children. So the concluding remarks of my talk, so 9 UNESCO Global Geoparks in Japan have been nominated, reflecting balance and geological diversity and geographical distribution. And geographical characteristics showing the diversity and ecology, climate change, and human life and culture. Every geopark in Japan has a risk from volcanic eruption or strong earthquake. And recently, typhoon damage became larger due to climate change. Inevitably, natural disaster risk reduction is an important issue for all territory of geoparks and people in Japan. Okay, terima kasih.
Thank you very much, Prof. Nakada, for
Yep.
giving us such information and interesting presentation. Okay, now come to the question and answer session. I'd like to have 2 or 3 questions for participants. Please use raise hand feature in Zoom, or you can write down your question in chat box. Let me check chat box. Okay. Okay. There is two question in chat box. Okay. The first one is coming from Isniwana. Okay, let me read your question. Here, I would to ask question. In Lombok, we have a Rinjani Geopark. There is a geological heritage, for example, caldera of Samalas, Rinjani volcano, waterfall, cave, and etc. As far as you know, how is the management of Rinjani Geopark currently? What is your advice regarding the management of Rinjani Geopark to make it even better?
Yeah, so 2 years ago, I visited there and I enjoyed the geopark during the conference. So the many interesting places very well introduced. So yeah, I didn't feel very big concern about the management of geopark, but my advice is you can use many places to learn the education of disaster risk reduction. So, and one other thing is 13th century, Rinjani experienced a very heavy eruption, very big eruption, VI 7. So that this was not introduced when I visited there. So that I ask you to introduce the huge eruption and the effect of preparation against the volcanic eruption near future. It's okay? Can you hear me?
Sorry. Sorry, Prof.
You can't hear my voice?
Yes, I can hear you clearly. Yes.
Yeah.
Sorry, I didn't unmute.
Yeah. So.
Okay. There is another one. The question is coming from Meriliani. Meriliani is asking in Bahasa. Let me translate. How often the volcanic activity? How often the volcanic activity occur in Japan? And does earthquake in Japan occur from volcanic activity or the others? Please respond, Prof.
So in the earlier part, I introduced to the frequency of Japan, and I said very few the volcanic eruption occur in Japan compared with Indonesia, and most of them is very small. So phreatic eruption, but even a phreatic eruption, several people died due to the attack by the stone from the crater. And the big eruption occurred in Fukutoku Okanova, just I introduced. But totally, the volcanic activity in Japan is very low now. So we are waiting a big eruption near future.
Okay. Okay. Mungkin the last one, maybe the last one question.
Yeah.
Oh, there are 2 questions. Is it okay, Prof?
Yeah.
Okay. The third question coming from Monica asks about the impact of geopark in climate change and green tourism. We know that currently there is a very drastic climate change. What are the efforts of Japan to solve this problem?
Yeah, so this is not easy to answer. So climate change distributed many places, including a geopark. So that the most important thing is how to realize the effect of climate change throughout many things in geopark and outside geopark. And the next action is how to reduce the effect or how to keep the present state for future. So that some education is very important. So, and for example, many geoparks are facing ocean or river, the picking up the clean the garbage or litters from the beach. So this is a very good exercise to learn how to keep the environment. So the water pollution does not directly influence the climate change, but due to the, for example, plastic is produced by the burning of CO2 or petroleum, etc. So that this is not the green energy. So that so to run the green energy or reducing carbon dioxide in the atmosphere is very good. Many chance to learn about that. So, yeah, for example, the case of the beach cleaning, and also the many disaster due to the flooding. Flooding occurred many times and strong the extent many were. Probably same thing occurred in Indonesia. So to prepare such a sudden flooding is a good education who learn the climate change like that. Yeah.
Pardon?
Yeah. Okay.
Can you hear me?
Yeah. Okay. Yes. Yeah.
Okay.
Let's go to the next question.
Okay. The last question is coming from Ardi Marwiliansa. Asks about, my simple question for you, how is our method for controlling of magma volcano and any more hazard for Japan volcanic activity?
Yeah. So controlling eruption is very impossible. So, but we can prepare the risks from the eruption. So this same thing said about the earthquake. So we can protect the happening of earthquake, but we can prepare the risks from earthquake. So this very same thing. So the probably many volcano eruption continued, and more bigger eruption may be expected in Japan. So very important thing is the how to prepare those eruption in Japan. So same thing can be said in Indonesia. So hazard map and yeah, the research itself is very important to know how volcano behave or forecast volcanic eruption next. But in addition, so preparing the how to reduce the risks from volcanic eruption become more important. So the hazard map, using a hazard map or some exercise and so on is become important. And in Indonesia, this kind of training or exercise very advanced, I think.
Thank you very much, Prof. Setsuya Nakada, for giving us some interesting information. And thank you for spending your time. We finally come to the end of the first session in this webinar. Before Professor Nakada leaving from this webinar, could you please give a closing statement for us, Professor Nakada?
Okay, thank you very much. So I was very happy to join this international webinar. And if you have any question, please ask me through the moderator or the Irwan and others. So the future collaboration through Geopark activity is very important for both countries, Japan and Indonesia. Well, thank you very much.
Thank you. Okay. Before we continue the second speaker, we will take a picture again with Professor Nakada. Is it okay, Prof?
Yeah, please.
Okay. Please turn on the camera to take a picture together. Ready? Wait. For all participants, please turn on the camera to take a picture. No? Okay. 1, 2, 3. One more. 1, 2, 3. Is it okay? Okay, we are done. Thank you very much, Professor Nakada, for spending your time to discuss with us.
Thank you. Thank you so much, Professor Nakada. Thank
You're
you
welcome.
so much for your
Thank
available
you.
science.
Terima kasih.
Terima kasih.
Terima kasih.
Okay, we continue to the second session. The second speaker today is Mr. Irwan, PhD.
Ya, sinyal saya kurang bagus ini. Oke.
Let me show. Okay, let me show you. Okay, I can hear clearly, everyone. Before the presentation begin, may I introduce the second speakers today. The second speaker today is Mr. Irwan, PhD. He is a PhD student at Tohoku University, Japan, and his research in collaboration with Japan Agency for Marine Earth Science and Technology Adelphi University, New York, and Merum. Research student in Gemtech, and then postgraduate IODP Integrated Ocean Drilling Program project meeting in Bremen, German, and now he is a lecturer in Islamic State University of Mataram. Okay. This ready? Before we begin, let me briefly explain the rule of this second session. So we have a total 45 minutes for this second session. Perhaps Mr. Irwan will deliver talk about 30 minutes for the talk, followed by approximately 10 minutes for a question and answer session. Ladies and gentlemen, now allow me to welcome the second speaker, Mr. Irwan, PhD, to deliver his presentation. Prof. Mr. Irwan, PhD, the time is yours.
Thank you so much, Mrs. Nur Hasanah. At first time, I would like to say thanks to all of you for your available times to join our international seminar about the volcanic activity and geopark in Japan and in Indonesia. Okay. Could you hear my voice?
Yes.
Okay, thank you. At this moment, I would like to discuss with you about the volcanic eruptions and geopark in Lombok, Indonesia. When we talk about the volcanic eruptions, excuse me, okay. When we talk about the volcanic eruptions, the most we should understand is our Earth's dynamic. Like these figures, you can see in this figure, the left figures. This is our Earth's dynamic in the subsurface. The yellow colors is the core, molten cores, and the red colors is the deep mantles, and the brown color is the crust layer, and blue color is the seawater of ocean, and the right side is the continental crust. The white circle you see here is the convection process in the mantle layer. The mantle layer is very hot. Approximately temperatures is 4,000 degrees Celsius. But in the bottom part is more higher temperature than the upper part of mantle. So the hot mantle will be moved to the upper part and cooling here in the upper part, and the cool mantle will be moved to the down part. So this process make the convective layer, convection layer, convective process, and make the oceanic crust move like these directions. In this figure, we can see two type directions. First, we can see here with the difference direction, we call it the divergent boundary. Divergent boundary, we can see in the different boundary, there is one direction to the left side and one direction to the right side, and make crust in the ocean broken, and magmatic plume come out to the surface. When the come out at the surface, the magmatic material becoming cooling by the cool seawater, and becoming the igneous rock and the new crust in the oceans. In another way, the magmatic from the molten core also intrusive to the surface and create the submarine volcano. The example in Indonesia maybe Krakatau volcanoes. And then the boundary in the right side you can see here is the convergent boundary when the oceanic crust colliding below the continental crust. We can see the bottom figures here, the convergence boundary. When the oceanic crust, the brown color here, subduct the continental boundary, and friction between the oceanic surface and the continental surface make increasing the temperatures and melting the rock. And for the long times, the melting rock will be becoming more bigger and make a magma chambers, the yellow color you can see here. And then the magma chamber is a very high temperature and pressure, and then okay, in the right figures, you can see the map of the convergence. I'm sorry, excuse me, this screen. Oh, slowly. It's okay. Okay, I'm sorry, there's a little bit trouble. Okay, this is this figure in the right side. You can see the map of the earthquake activity and then volcanic activity around the world. The red lines is the convergence zones when the volcanic activity, and then the yellow dot is the earthquake. The earthquake and volcanic also together, mostly always together, including in Indonesia. You can see that there is a lot of earthquake in Indonesia, Japan, America, and this region we call it the Ring of Fire. How the earthquake occur is when the subduction zone, like here, like you see here, is stuck. This is lock interface. When the oceanic crust stop and cannot move, but the motion still continues, it will make broken the oceanic plate or continental plate. When the oceanic plate broken, it will occur the earthquake, great earthquake. When the great earthquake, the scale more than 7 Richter scale, and location close to the beach, and the typical of earthquake is a normal fault or the thrust fault. It will cause the tsunami in the continental land. The example for volcanoes in Lombok Island, we can see there are 3 volcanoes in Indonesia, in the Lombok Islands. In the West Lombok, we can see the Unikan volcano. This is the old volcano complex, estimate in Neogene Pleistocene age. And then the second one is Rinjani volcano. This is the youngest volcanic complex, 1,000 until 6,000 years ago. And in the eastern Lombok, we can see that there is a Sembalun caldera and a Nangi volcano, the old volcanic complex. The Sembalun complex estimate age 0.45 million years ago, Pleistocene Holocene with the remaining caldera composed of andesite lava and pyroclastic. This is how the Rinjani volcano Rinjani volcano. This is the simulation of the Samalas volcanic. Excuse me. Okay. This is a Samalas volcanic eruption. You can see a lot of the ash pyroclastic to the atmosphere. Based on the previous study, the pyroclastic from the volcanic of Samalas eruption until the 43 kilometers to the atmosphere. So very big volcanic. The volcano index is 7. It's the highest. Like we had Satya Nakada Sensei explanation is the highest big eruption is 7 index of volcano. And during the pre-Samalas eruption in the 13th century, there were 2 volcanic cones, which were Samalas here, Samalas here, with the elevations is 4.2 thousand meter, and then Rinjani is 3,000 of the Rinjani volcano. And how the process is so big eruptions. In this figure, we can see in the Holocene, the pre-caldera activity, the figure A here. There are 3 magma chamber here. You can see here in below the Samalas cone and Rinjani and Propok. And then in year 1057, the 3 magma chamber mixed to be one big magma chamber. So the pressure is very high. The temperature is very high. So because the pressure is very high, they try to push out and create the very strong volcanic eruption like we see in the left figures. And this is the recent conditions like in the figure C. The magma chambers is very small. So that's why the volcanic eruption in Anak Gunung Jari, Anak Baru Jari is little is not so big, the eruptions. This is the impact of mega eruption of Samalas volcano, like you see in these figures. This is heat flux intensity in Europe. So the effect of the volcanic ash of Samalas eruption is until the Europe. That's why you can see in these figures, the heat flux in the atmosphere is very low. The heat flux means that the sunlight cannot enter to the earth because the atmosphere coverage by the volcanic ash. So the weather at that time is very cool because there's very low heat flux from the suns. Like you see in the A figures in the left side, the blue color, that means very low heat flux. Here in the Europeans, England and France and Spain, and that means very low heat flux. And then after 1 year, the heat flux increased. The heat flux increased in England, but France and Spain and then in the Eastern European is still low heat flux. And after 2 years,
Excuse me, Mr. Irwan. Maybe there is some trouble in your voice. We cannot hear clearly.
I'm sorry, there is a little bit trouble. Excuse me, you can hear my voice? Okay, thank you so much. Yes. In this slide, we can see the impact of mega eruption of Samalas volcanoes. This is in the left figures. We can see the isopah maps. That is the thickness measurement of the volcanic ash in the field for Samalas Plinian and Plitophyllinian fault deposit compared with the Plinian fault unit in Tambora. And we can see in this map in Lombok Islands, this is Samalas volcano eruption, and then in Sumbawa, in Dompu here is the Tambora eruption. We can see, we can compare how the thickness of the volcanic ash in Tambora and Samalas eruption is very strange difference. For Tambora, we can see from 5 to 20 meters, but in Samalas volcano, we can see from the 20 to 90 meters the thickness of the volcanic ash deposit. That means the Samalas volcano eruption is the more bigger than the Tambora eruption during the 15 years ago. And this is the example. The Samalas eruption deposit as fall in the Sedau Valley, 25 kilometers southwest from the source. The Sedau Valley close to the Lantan in the central Lombok. Excuse me. How to? Okay. And this is the reconstructions of Samalas. Excuse me. This is a reconstruction of Samalas and Rinjani volcanic cones. We can see here during the Samalas eruptions, there is a very big caldera, create after the Samalas eruption, and then the Rinjani cones collapse to the caldera of Samalas. We can see here. And then the diameter of Segara Anak Lake of the caldera of Samalas after the eruption is 6 kilometers. And this is Baru Jari cone. And then these figures, the B figures, is the reconstruction result of Samalas and Rinjani volcanic cones. And this is the you can see here is the black colors here is the Mount Rinjani cones with the high elevation is 3.7 meters, 3.7 thousand meters. And then the right side, the black colors here is former of Samalas mountains with the cone elevation is 4.2 thousand meters. And this is one of the sector collapse, and corresponding to the left side here. Because Samalas eruption is have the global impact, so Samalas eruption becoming proposed to be the one of the geopark site, global geopark sites. Geopark is a unified area that advances the protection and use the geological heritage in sustainable way and promote the economic well-being of the people who live there. That means the geopark to keep the geological heritage, natural landscape, natural landscape, and also to growing the economic and culture for the people who live around the geological heritage. In year 2013, the Rinjani Geopark Lombok as National Geopark, and then 5 years later, in year 2018, Rinjani Geopark Lombok was to be UNESCO Global Geopark. And this is a geopark site of Segara Anak Lake. We can see the beautiful landscape here, the eruptions of the Gunung Anak Baru Jari here, and it's very continuously and make the Segara Anak Lake area becoming narrow. Here we can see that the new land will be formed in Danau Segara Anak Segara Anak Lake. In Segara Anak Lake, we can see a lot of activity like camping, Pancaka Mulang Pakelam, which is the Hindu ritualism every 5 of November. And also we can do some fishings and hot spring bath in the Segara Anak Lake. And then next is geopark site of Sembalun Caldera. Sembalun Caldera have beautiful landscape. You can see in this figure. Last August, I with my team had investigated the volcanostratigraphy in Sembalun, and you can find there are 29 volcanostratigraphic units with 7 volcanic phase. We have analysis from the oldest volcanic rock until the youngest volcanic rock. We can see in these figures, the oldest volcanic rock is the Gunung Pegasingan in the north part here. You can see here the brown color. The brown color is the oldest volcanic rock. It's Pegasingan volcanic rock, and we can see the some of the fingerprints of the crater of the Pegasingan volcanic activity here. And then after Pegasingan volcanic rocks, and then continues by the here is what is the Gunung Gunung Anak Dara rocks. This is the first Gunung Pegasingan rock, and then Gunung Anak Dara rocks, and then Gunung Monjet, and then Gunung Nanggi, and the most youngest volcanic rock is Pusuk volcanic rock here in the central caldera of Sembalun. In Sembalun caldera, there is some of cultural events we can see here in the left side, and then because the soil is very good for plant, so it can be make growth of the economic local people. And the next is geopark site in Aikalak and Sabau Hot Spring. We can see in the left side. This is the Aikalak Hot Spring around the Sembalun Geopark, and then in the bottom part is Sabau Hot Spring around the Sembalun Geopark. How the hot spring appears in the surface. This is we can see in these figures. This is the geothermal system of the hot spring. In the geothermal system, we have 3 components. First, we should have hot rock, and the second part we have a reservoir here, the blue color and blue and red colors, and then we should have cap rock, so the water doesn't go out to anywhere. And then we can see here in the left side, there is recharged water from the rain or meteoric waters. This is cold waters, the blue colors. and also from the right side, the blue arrows that means the cool waters, and this cool water will be boiled by the hot rock in the reservoir and becoming the hot waters. This hot water have the high pressures and then high pressure and high temperatures. Because they have a high pressures, they will try to push out to the surface, and we can find the hot spring or hot water in the surface, like in Aikalak or Sebau hot spring. And the next geopark site is Nipah Beach. In Nipah Beach, we can find philo lava. This philo lava is caused by the magmatic hot rock, melting rock, cutting the rock formations, and then because the cooling seawater make the make the hot water becoming cool and make the lava rock becoming the igneous rock, like the figures in the right side. And also in Nipah Beach, we can find the dike. The dikes means some magmatic or hot rock intrusive the rock formation, like this form. And this is the volcanic rock, lava volcanic rock. And then in the geopark side, we also have the lot of the waterfall. The waterfall in this figure, we can see that the many type of the waterfall. The waterfall from the river water, and also from the cutting of the aquifer layer. Example, in Sendang Gila waterfall and Tiusakaper waterfall, the river the water from the river in the surface. But in Benang Kelambu, there is no river waters, but the water from the aquifer layer cut by the normal fault. So the water is very clean and very safe to the drinking, because the water is not contaminated by the surface water. And also in Tukalep, there is two types. First, in the surface, the river water, and also from the aquifer layer water. Because the earthquake of volcanic activity, the rock here is collapsed or fault down, and make the part of the rock becoming down and with the normal fault. And then we can see that the aquifer layer cutting, and you can see that the water come out from the wall of the volcanic rock. Thank you.
Thank you very much, Mr. Irwan PhD, for such information and interesting presentation. Okay. Now come to the question and answer session. Is there any question in chat box? Okay. I have already 3 questions here. 3 questions here. Let me see. Okay, the first question is coming from Mr. Asmar. Asks about there is a lot of tourist potential that has been developed from the Rinjani Geopark. In your opinion, what is the current level of the geopark management
Oh yeah.
Is the management optimal or not?
Yeah.
And is there still hidden potential of this geopark that is possible to be developed?
Yes. At this time, the geopark development focus on the central to northern part of Lombok. For the next time, the geopark will development program to the all Lombok Islands. Yeah, including the northern part, southern part of Lombok, because in the southern part we can find the oldest volcanic rock from the Oligomyosins, approximately 11 to 12 million years ago in the Sekotong area, and yeah, in the Sekotong area. This is also one part of the geopark site interesting for the development on the futures. I think so. Yes.
Okay, thank you very much for your response. There is the other one. The second question is coming from Desti Ananta. Asks about, I want to ask question about Lake Segara Anak. I have heard that one day the water in Lake Segara Anak will decrease so that the water run out.
Yes.
I want to ask through the process whether the lake water will recede. What is recede? Will recede.
Yes.
Can you see?
Yeah, I see. I
Okay.
understand. For the future, maybe the water in Segara Anak Lake will be loose because the material volcanic from the Baru Jari Cone still continues and make all the area of the craters will be closed because the sedimentation of the Baru Jari volcanic material. Yes, I think so. Like we see here, every years the sedimentation of Baru Jari Cone volcanic will always increase. So the area of the water will be decreased like that. So maybe I don't know how many years all the area will be all the area of the Segara Anak Lake will be covered by the volcanic material from the Baru Jari eruptions. Because Baru Jari eruption, Baru Jari volcano is active volcanoes and still continues to the erupted, even though there is eruption is very small, but they still produce some of the volcanic pyroclastic and deposit around the Segara Anak Lake and make area of the water decrease. Yes, I think so. Thank you.
Thank you very much for your response. The last question is coming from Monica. Asks about, where is it? Let me check. Okay. Monica asks about the slide presentation explained that scientists were able to reconstruct the formation of cone from Samalas and Rinjani volcanoes. How do they reconstruct the formation? What method did they use? And how accurate are the results of this reconstruction with actual event?
Oh, okay. Thank you so much for your questions. Okay. Okay. How to reconstruct the cone is okay. How to reconstruct the cone of the Mount Rinjani and former Samalas mountains. In this reconstruction, they use the polymetric and mass of the material volcano loose. Volcanic loose, because during the eruption we can see a lot of the whole body of the Samalas volcanoes loose after the eruptions to the atmosphere. So the scientists try to investigate the where the deposit of the volcanic material up from the Samalas. They do it like coring, and they measure the thickness of the Samalas material eruptions like volcanic ash, and then they do it measurement around the Lombok area. From all this material, they calculate the volumetric of the mass material from the Samalas volcanic eruptions. And the second ones, they do it like geochemistry analysis. From the geochemistry analysis, we can also one variable to the calculate the to reconstruct the cone of the Samalas cone in here. I think so.
Okay, thank you. I think we still have time, maybe 3 minutes again. There are 2 questions here. The question is coming from Habib. Asks about Lombok is beautiful island, but too dangerous for people. How to be prepare and manage also the too educational to the people living. Now about the exploration of water thermal as electrical can have any effect to safety people living there? Thanks. Maybe just short explanation.
Oh yes. Okay, thank you so much, Habib, for your very good questions. Yes, of course, Lombok is have very beautiful landscape, but also we have so many disaster potential. So mitigation, geohazard mitigation is very important for us to study from the formal education, like from the senior high school or from the university. That means every people who live in the dangerous area should be understand what the kind of hazard or disaster potential in their homeland. So in the future, we will try to give some education from university to senior high school to educate the people what is disaster potential in close of their home. And then we also would like collaboration with the governments, how to decreasing the hazard potential in our homeland, especially in Lombok Islands. Thank you. So there is some collaboration between the university and government, and also there is a collaboration between the university and then with the society. I think that.
Okay, thank you. This is the last question today. Is coming from Abdul Habib. Asks about how is the process of formation of all waterfall in Lombok, right from the eruption of Mountain Samalas. What is the process?
What is the process?
Yes.
Like I have explained before. Okay. Samalas volcano is the youngest volcano. I have this explained before. The age probably approximately 12 until 6,000 years ago. And then we can see here, we can see in these figures, there is some of magma chambers. There is three magma chambers here below the Samalas cone and Rinjani cone and Propok cone. And then the three magma chambers mixed together to be one big magma chambers. So the size of magma chamber is so big. That's why the pressure of magma is very high. Because the magma chamber is very high pressures, when the volcanic eruptions should be produce the very high eruption, like in these figures. The eruptions, the material eruption, the pyroclastic eruption until 43 kilometers, because very high pressure from the magma chambers. And the shallow, we can see here, the shallow magma chamber depth. The shallow magma chamber depth with the high, with the very big magma chamber size. So that's why the Samalas volcanic eruption is very big, because the size of magma chambers and the shallow depth of the magma chamber positions. And the recent condition is magma chambers is the in a deep positions with the small size of the magma chamber right now. So our land, our island in Lombok Islands means is very safe for the big volcanoes at recent times. So don't worry about that. Thank you. Oh, yeah.
Okay, thank you very much for such information and interesting presentation. Okay, ladies and gentlemen, we finally come to the end of this webinar. Before we close this webinar, please turn on the camera.
Closing speech.
Camera to take a picture together. Please give a closing statement for us, Mr. Irwan.
Thank you, Mrs. Nur Hasana.
Thank you very
as
much.
we know that our island, Lombok Island, is very beautiful, beautiful islands. We have so many beautiful landscape like waterfalls and also some beautiful beach. But also we have big potential for disaster like a landslide and also water flood. Landslide potential we can see especially in Pusuk. If you want to going to Sembalun, please be careful, because a lot of the volcanic ash deposit in there is very potential for the landslide. And also in the western part of the Lombok in Senggigi area is very dangerous for the landslide, because the rock is weathering process. The rock is weathering process, and easy to accumulate the waters, and also very potential for the landslide in the western part of Lombok. I think so. Thank you so much for this interest for this time to discuss with you.
Thank you very much for spending your time to discuss with our webinar. Okay, please give applause for Mr. Irwan for today. Okay, we finally come to the end of this webinar. Thank you very much for your attendance. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
wabarakatuh.
Waalaikumsalam warahmatullahi
wabarakatuh. Foto bareng. Udah. Foto bareng sudah. Oh.
For information, please fill the link attendance in chat box. Okay, the certificate will be sent by email. Thank you very much.